Hi guys, this is Dr. Manjunath Chennapagod from Anveshana Academy, Bangalore, India. Dear students, in the previous class we discussed various numericals on Otto cycle. Today I am going to take next concept, that is diesel cycle. So next cycle is diesel cycle. As we know, there are three important cycle, air standard cycles will come in that: Otto cycle, second one is diesel cycle, third one is dual cycle. Okay, so dear students, we studied what is Otto cycle and what is the equation for Otto cycle, that is efficiency equation for Otto cycle, that also we have derived, and also around 5 to 6 numericals we solved on Otto cycle. Okay, now I will move towards the next cycle, that is diesel cycle. So before going to study the diesel cycle, why the diesel cycle is invented, you can see, dear students, he is the Rudolf Diesel. He is a German engineer, Rudolf Diesel is the name actually. So he invented the diesel engine, hence we kept that cycle name as a diesel cycle. What is that? Diesel is the name of the scientist. Okay, so now, dear students, why this diesel engine is invented? So we know already before that we studied about steam engine. Steam engine itself, it is having some demerits, okay, because we need to have a external combustion. From that we need to take a steam, then with the help of that steam, what we have to do, we have to supply that steam to the engine. Steam engine is going to do some amount of work, but there is external combustion. For that external combustion, what we have to do, we have to burn some coal or wood or some any other kind of fuel, but it is very bulky and it is complicated, and whatever the efficiency you are getting from the steam engine is less actually, because more amount of heat is going to loss in that particular steam engine or external combustion engine. So later what happened, so this what steam engine, before the steam engine, one more scientist, Huygens, in the 1682 Huygens tried he tried to develop an engine with the help of a powder, that is what gunpowder. He tried to run the engine with the help of gunpowder in the 1682, but it has a lot of drawbacks, hence therefore what he has done, that is not came into the applications. Later what happens, thus James Watt, that one small story also I told you. James Watt, what he has done, he has done lot of experiments and he invented an engine. That engine is the what? Steam engine. But that steam engine is external combustion engine, it is having a lot of demerits. It is a bulky and design complicated and less efficient. Hence in the 1862 Nicholas Otto tried to invent a new engine, that too internal combustion engine. Hence he had done a lot of experiment, because steam engine having a lot of drawbacks are less efficiency and more more heat loss and less power generation. Hence what he has done, to overcome these all challenges, he tried to invent an engine that must be internal combustion engine. That means the combustion has to take place inside the cylinder of the engine. In that direction he worked a lot and he has invented an engine. That engine is the what? Petrol engine, or we can call it as a gasoline engine. To develop that engine, he has given a cycle. That cycle we can call it as a popular, you can call it as a Otto cycle, in the year 1862. But so that he has started to Otto came, but that Otto cycle developed engines like petrol or gasoline engines, they are having some drawbacks again. So in this, what drawbacks it is having? Less compression ratio, less efficiency, okay, less efficiency, and they are going to produce low power. But for heavy applications like truck, lorries, railways and JCBs or so many actuator machines, it is very difficult to use them Otto cycle engines or petrol engine or gasoline engine. The students, we can see in our day-to-day activity also, only car and bike we can see petrol, but whereas bus, lorry, you can take a truck, you can take a trains and all those things, they're using diesel. Why? Because the diesel operated engines, they're going to give more power. So hence what happens, so one more scientist came in the year 1892, in the year 1892, that is German engineer Rudolf Christian Karl Diesel. He started to resolve these challenges. Now what are the challenges? We are having petrol engine, low power, one thing, and less efficiency, less thermal efficiency. Okay, they are restricted for only small applications, not heavy applications. So but what to do for the heavier applications? He had done a lot of things and he has done a research, he invented a lot of things himself. Then he came to know that we need to develop an engine which is having more thermal efficiency and it should produce more power. In that direction he started to work, and later he invented an engine. That engine we can call it as a diesel engine, or we can call it as a compression ignition engine. Then on what basis, what is the motivation for him to invent the diesel engine? So dear students, we can see now, because petrol engine, okay, it's having an applications, but applications are limited. Petrol engine applications we can see car or bikes only. Okay, hence he came to know that the efficiency of the auto cycles, auto engines are less, but he aimed, we need to identify, we need to invent a new engine which is having more thermal efficiency compared to gasoline engine. He started in that direction. We have to develop an engine, that engine has to give more thermal efficiency than the gasoline engine, one thing. And also he thought, whatever the petrol and diesel engine having, right, it's a not for a heavy duty applications. Hence he started to invent we need to invent an engine, it should have more durability and it should be applied for the heavy duty application. This is also his second motivation to invent the diesel engine. Next, fuel versatility. That means what, dear students, when it comes to petrol engine, we can say petrol engine that is developed by the Nicholas Otto, but we can only use gasoline or petrol. That same petrol we can use, but other than that we can't use any kind of fuel to run the petrol engine. That is one of the major drawback or demerits. But when it comes to then he thought that we need to design or develop an engine, it should use different kinds of fuels, to run the engine. What are the fuels? I will tell. Okay, now that also he kept in mind to start before starting the invention of the diesel engine. And once we invent an engine, right, that engine should have more and more applications, because in petrol engines we can't use in industry, we can't use more in the transportation. We can take lorries, logistics, you can take ships, you can take marines, you can take heavy applications, right? We can't use them petrol engines or gasoline engines. But we need to develop an engine, that engine should have more impact in industry, more impact on industry, and also it should have more advantages in the transportation. In that direction he has started to work on an engine to overcome the all drawbacks of the auto engines. Then what all things he has done, you can see here now. So the first motivation for Rudolf Diesel is what? He aims to design and develop an engine which should have higher thermal efficiency, he started to work on that concept. But whatever the engine we're having at petrol engines, right, the efficiency of that petrol engines was around 20 to 25%, but it's very less. Out of 100, if it is 20 to 25%, is very least. Then he tried, now the efficiency is very low, we need to invent an engine that should have more thermal efficiency. That is a first motivation he got. Yes, we need to design and develop an engine, or we need to invent an engine that should have more thermal efficiency than the gasoline engine. This is the first motivation. In that direction he came to know that while doing a lot of experiment research and literature survey, he came to know that compression ignition engines will have more thermal efficiency. So he came to know that during experimentation or during research or literature, we came to know that compression ignition engines will give more thermal efficiency. Okay, then what he has done now? Yes, he came to know that more compression ignition engine will give them more thermal efficiency. Yes, then what he has done? He developed an engine which is having higher compression ratio. Higher compression ratio means what? Dear students, petrol, you can see, I will tell you the difference between Otto cycle and diesel cycle, or petrol engine and diesel engine difference I will tell later. But petrol engine having 8 is to 1 to 10 is to 1 compression ratio. But diesel engines, they're having 14 is to 1 to 22 is to 1. That means what you can see, the compression ratio in the diesel engine is more. That compression, if the engine having more compression ratio, means it is going to produce more power as well as more thermal efficiency. This was his concept. Hence what he has done, he started to develop a higher compression ratio engine to get the greater thermal efficiency. Yes, he done that. He developed the engine and he compared the efficiency of the higher compression ratio engine with the lower compression ratio engine. That higher means what? Diesel engine he compared with the petrol engine, because in the diesel engine he used the fuel as a diesel. That I will come later. Okay, then compression ignition CI engine, we can say compression ignition engine which is having higher compression ratio gives, he came to know that will give more thermal efficiency, that up to 30 to 40% efficiency. The thermal efficiency of the higher compression ratio ignition engines given 30 to 40% of efficiency compared to petrol engine, whereas petrol engine is how much? 20 to 25%. Hence what he has done? Yes, he achieved the higher thermal efficiency from the what? Higher compression ratio engine. Then also he has done a lot of work. Then whatever the engine he has developed, right? Yes, he came to know that it is going to give 30 to 40% efficiency, and also he has done a lot of work, and he came to know that whatever the higher compression ignition engine or compression ignition engine will give more durability, and also it is going to have a longevity, and the duration is more, and that can be used for the heavy duty application. He tried to use that engine for a heavy duty application and he got succeed. One thing, and also when he developed that engine, right, there was one drawback. Major drawback was what? When it comes to Otto cycle, we need to use only gasoline as a fuel. But he came to know that compression ignition engine, in that compression ignition engine we can use different types of fuel. That means what? Fuel versatility is there in the compression ignition engine. I mean, in the diesel engines we can use various types of fuels, like you can see diesel. Okay, we can use biodiesel, we can use biogas, we can use CNG, we can use producer gas, we can use bio CNG, we can use, and also with the help of biodiesel plus some additives also we can use in the diesel engine. These many options we can have in the diesel engine or compression ignition engine. Because of this reason, high thermal efficiency and more power production and application of different fuels in engine, hence it got more impact on the automotive sector as well as industrial sectors. In the automotive sectors, the people who needed high power and high thermal efficiency with fuel versatility, they started to use the compression ignition engine. And also in the transportation, you can take a bus transportation, you can take a ship transportation, like that. So what they will do, the people started to use the compression ignition engine as they required high thermal efficiency and more power. This is what the history of the diesel cycle. This was the history of the diesel cycle. Dear students, before the diesel cycle, steam engine, auto cycles was there, but again you can compare diesel engine with the steam engine. Again, steam engine is what? External combustion engine, whereas diesel engine is what? Internal combustion engine. But the efficiency of the diesel engine is more when compared to steam engine. The steam engine is complicated and it is bulky. When it comes to diesel engine, is a compact and simple in design, and it is having a more thermal efficiency. Hence the people they started to use diesel engine in the heavier applications. Okay, fine. Okay, now what is the diesel cycle impact? Now we came to know that diesel engines having more thermal efficiency, more power, and we can use different kinds of fuels, that too. Okay, then because of that only we have started to use the diesel cycle, diesel cycle or diesel engine we can say. Then what it does actually, that is going to address the limitations of the gasoline engine as well as steam engines we can consider. The cycle is designed to overcome the existing engine efficiency. As I told dear students, the efficiency of the, we will compare with what, Otto cycle only, because Otto cycle is, Otto engines or Otto cycle is better than the steam engine. Auto engines are better than the steam engines, we know that. But now we are comparing auto engine with diesel engine. The auto engines, what they are giving, they are giving only 20 to 25% efficiency, but this is a drawback now. But what we have done, diesels work, and he proved that diesel engine will produce 30 to 40% of efficiency. That is that challenge was addressed by the diesel engine to overcome the drawback what we are having in the petrol engine. Hence what happens now, when we started to use the diesel engine, right, we got the enhanced thermal efficiency. Efficiency is improved than the petrol engines. Then what happens now if it is having since it is having more thermal efficiency, more power, what we have started to do, we started to use that diesel engine into compression ignition engine or diesel engine into industrial applications. Somewhere we have started to use to convert the energy, conversion of energy. What type of conversion energy you can take? Conversion of fuel energy into electrical energy. What we done, we started to build a thermal power station which is operating on diesel, small thermal power station. We can see it in our when we are going to keep one generator as a backup, right? Diesel operated electrical generator we are using in our day-to-day application, right? Such kind of applications they have developed. Then they have started to generate the electricity with the help of a diesel engine. That engine is in diesel engine, what it started to do, it is going to convert one kind of energy into electrical energy that can be used for our day-to-day applications. That is they have done. Next, as it is having more thermal efficiency and power, what we have started to do, we started to use in the transportation sector also. Hence that engine, what is proved, it is having more durability and we can use it for the heavier application. And that engine life is longer than the petrol or gasoline engine. And that engine, why we are using that diesel engine, that is compression ignition engine for heavier applications, means it is having it is going to provide fuel versatility. That means what, different kind of fuels we can use to run the compression ignition engine. So this is the motivation for a diesel to get a more thermal efficiency, to get a more power, to use the different kinds of fuel. Okay, so by keeping these all things in his mind, what he has done, he started to work on the engines and he came to that we can resolve these all challenges with the help of a compression ignition engine. Then he worked on that compression ignition engine by keeping higher compression ratio. Then he achieved that we can get more thermal efficiency, that up to 30 to 40%, and we can use the different fuels and we are going to get a more power. That more power we can use it for the different heavier applications. He came to know that and he proved and he given that diesel cycle. Based upon that diesel cycle, what we have done, we started to design the engines. That engines we will call it popularly we will call it as a diesel engines. The diesel engines are nothing but what? Compression ignition engine. How it works, that we will discuss in detail. Okay, now this is what history of the diesel cycle. Okay, now so when it comes to this diesel cycle, how many stages are it is going to have? Yes, dear students, there are 4 stages in the diesel cycle. We know already, right? Diesel cycle play a very important role to design the diesel engine. Okay, so then how that diesel cycle works, what are the important stages are there in that diesel cycle, that we will study it here now. First one is isentropic compression. Second one, constant pressure heat addition. Third one, isentropic expansion, fourth one constant volume heat rejection. These are the four important stages in the diesel cycle. Okay, how it works now, dear students? Again, as I told, we know already the piston movement from BDC to TDC. You can call point 1 to point 2. When assume that what is isentropic compression here now, the piston is moving from point 1 to point 2. That means what? BDC to TDC. That is what? Whatever the but here, dear students, you can see it in the Otto cycles, air fuel mixture is getting enter into the cylinder, but here only air is getting enter. That you have to keep it in mind during suction. That we will start with compression. Actually, before that suction, before that compression, we are having a suction. In that suction process, what we are doing, we are going to suck the air into the cylinder, only air. Okay, so now air is there already. When the piston is start to move from BDC to TDC, I mean point 1 to 2, what happens? The air, whatever it is there, right, it will be get compressed. So when it is going to get compressed, right, but during that compression, you have to keep it in mind that there is no heat transfer from system to the surrounding. If there is no heat transfer during that process, that means what? Compression process, that we can call it as adiabatic compression. If it is going to happen suddenly, right, so we can call it as isentropic compression also. The air is compressed adiabatically. That means what? There is no heat transfer at all. That is the first process. That is the first process. Okay, once air gets compressed, it is the temperature of the air is increased sufficiently. It is going to increase. At that moment, what we are going to do, the pressure is going to attain in the cylinder is constant. Okay, at that constant pressure, what we are going to do, we are going to supply certain amount of heat here now. Dear students, you can see it in the petrol engine. What we are doing, we are going to give a spark, then combustion will take place. But here air is already gets compressed. The temperature of the air is increased around 200 to 250 degrees Celsius. At that moment, what we are doing, with the help of fuel injector, we are going to supply a small quantity of diesel. Once you are going to supply small quantity of diesel, what will happen? Sudden combustion will take place. That means what? Fire will take place, because the flash and fire point of the diesel is around 45 to 55 degrees Celsius. The temperature of air is already 200 degrees Celsius. Then what will happen? If you give a small quantity of diesel into that compressed air, which is having 200 degrees Celsius temperature, then what will happen? Sudden combustion will take place, or sudden fire is going to occur. Okay, that means what? You are adding heat at constant pressure. Okay, that is second process. Because of that heat combustion, immediate explosion force is going to create inside the cylinder. Then what happens? The piston will start to move from TDC to BDC, or from point, you can call 1 to 2, you call it as a process 1. Then other process I will mark it here 3 to 4. Then what happens? Piston will start to move from 3 to 4. That is nothing but what? Isentropic expansion. During expansion also, heat transfer is zero. That means what? There is no heat transfer. That process we can call it as a adiabatic expansion process. That also taking place suddenly. That means what? Isentropic expansion. If it is expansion, then we are going to get work at the crankshaft. Okay, this is what? Third process. Then fourth process, once the piston reaches BDC, right, then what we are going to do, we are going to open the exhaust valve. Hence, whatever the hot gases is there, right, which is already burnt, that hot gas will come out to the environment. Hence, what will happen now? The heat is going to reject. That heat rejection we can mark it as a QR. There is some amount of heat rejection. So that we can call. Again, how it is going to happen now, dear students, that you have to see it now. But the heat rejection is going to take place here. Constant volume remains constant. That we can call it as a constant volume heat rejection. This is how the diesel cycle works. Actually, these are the four important stages in the diesel cycle. On these stages only diesel cycle works. With help of these stages, we are going to derive a thermal efficiency per the diesel cycle in the next class. Okay, fine. Now I will move towards comparison between Otto cycle and diesel cycle. Before going to that, we should know some terminology of the engine, because both petrol and diesel engine or Otto cycle operated or diesel cycle operated engines having combustion inside the cylinder. Hence what will happen now, we can say both are internal combustion engines. But what are the small changes that we can see here now? In the petrol or gasoline engine, we are using spark plug to give the heat or to add the heat. What we are doing, we are using a spark plug. But when it comes to compression ignition engine or diesel engine, we are using fuel injector. But both engines, they are going to have combustion chambers, okay, piston they are going to have, cylinder they are going to have, they are going to have a connecting rod, and they are going to have a crankshaft, okay. Then both having swept volume, clearance volume, both having BDC and TDC, both having cylinder head. But when it comes to inlet and exhaust valve, in petrol engines we are having inlet port and exhaust port, but in diesel engine we are having inlet valve and exhaust valve. When the piston is at different positions, right, when it BDC you can call it as a 1, when it is TDC it is you can call it as a 2. But 1 and 2, it going to represent the pressure volume and temperature of the air fuel mixture. Both side you can take petrol as well as gasoline engine, P2, V2 and T2. So these are the terminologies we can see. Now dear students, I told, so what is this now, swept volume I told somewhere, right, VC. What is that VC that we can see here now? That's also important. 1 minute. Okay, what is VC? Here I am marked, right, VC, that is nothing but what? Clearance volume, the volume occupied by the air fuel mixture from cylinder head to the TDC. This volume you can see, if the volume occupied by the air fuel mixture from TDC to cylinder head, we can call it as a clearance volume. The distance between cylinder head to TDC, we will mark it as a X, where X is the distance between TDC to cylinder head. Then whatever the volume we are going to get in that distance, right, that volume we can call it as a clearance volume, that is represented as a VC. Then we are going to get one more volume here. That volume is nothing but what? Swept volume, VS, that is swept volume, it is represented as a VS. The volume between BDC to TDC. Assume that if the piston is at TDC, whatever the volume we are going to get from TDC to BDC, right, that volume we can call it as a swept volume. The distance between BDC to TDC, we can call it as a stroke length. Okay, the stroke length is the distance between BDC to TDC, that we can call it as stroke length, that is represented as a L. With the help of that L, what we can do, we can calculate the swept volume using a standard equation, cylinder equation, that is what? 5/4 into d square into L. Okay, that is what? Stroke length and swept volume. And one more thing we are having, dear students, here now, D here now. As I taken D here now, what is that D? D is nothing but what? Bore diameter here now. Just a minute. That you can see here now. D is nothing but what? Bore diameter, where D is the bore diameter or diameter of the inside cylinder, bore dia. Then L is the stroke length. Okay, then with the help of this, what we can do, I can calculate the swept volume with the help of these two, D and L. That is nothing but what? 5/4 is the constant into d square into L. With the help of this, what I can do, I can calculate the swept volume. Okay, fine. Swept volume and stroke length we know, diameter also we know. Then what is BDC? Where BDC stands for bottom dead center, TDC represents top dead center. Point 1 you can mark it as a point 2, because when it comes to cycles, right, we are going to represent 1 2 3 4 1 again. It's a cycle, so there it will help us. Okay, now when the piston is moving up and down, right, it is going to moving up and down, right, we are going to have a different processes now. One, we are going to have a compression process, one we are going to have a expansion process. When it is moving up and down, that's playing a very important role. When the piston is, if it is at point 1, it is going to have pressure and volume, air fuel mixture. Pressure and volume will be, pressure and volume and temperature will be P1, V1, T1. If it reaches the point 2, that means what? If the air fuel mixture gets compressed. But in petrol engine, air fuel mixture will be compressed, but when it comes to diesel engine, only air will be gets compressed. Air is only gets compressed. If it gets compressed, it is going to have a pressure, that pressure P2, it is going to occupy some volume, that volume we can call it as a V2, then temperature we can call it as a T2. This is what the overall view of how the engine works. What are the terminology we are using now? That's important small terminology what we are using in engine, that's playing a very important role in understanding both Otto cycle and diesel cycle, dear students. Okay, now we'll try to understand what actually the difference between Otto cycle and diesel cycle before moving towards diesel cycle. Okay, now you can see here, dear students. Now okay, so now this is the, you can see here. Now when it comes to diesel cycle, you can take a spark plug. When it comes to petrol engine, you can take a spark plug. When it comes to diesel engine, you can take a fuel injector. But in the suction stroke, in petrol engine, both air fuel mixture we are taking into the suction. But when it comes to diesel engine, we are going to take only air during the suction. Okay, then again VC, VS, BDC, TDC all will remain same for the both engine. But again diameter is going to change for petrol and diesel engine, because diesel engine having more bore diameter and petrol engines they're having less bore diameter. Why? Because diesel engines are more compression ratio. What is the compression ratio? That also we know already, right? It is nothing but it's the ratio of V1 by V2. That means what? Total volume V total divided by Vc. What is total volume? That also we have discussed in detail, right? Vs plus Vc. To calculate this Vs and Vc, we should know the bore diameter. That means what? 5 by 4. Vs already I told, right? Vs is equal to 5 by 4. Sorry, 1 minute. We know, right? So Vs is equal to 5 by 4 into d square into L. But whereas the diameter of the bore diameter of the diesel engine is more when compared to petrol engine. Why? To get the more compression ratio. Okay, so what that on that compression ratio you can do a number of research work on that. Many scientists, they are doing more number of research on that variation of compression ratio, and they're checking the performance of the engine. That research concept I will not discuss here. Okay, fine. If you want, I will take another different class and I can explain you now. Dear students, no, we know already what is Otto cycle. Otto cycle 1 to 2 is compression, adaptive compression. 2 to 3 is heat addition. At to what? At a constant volume. Volume remains C, constant here. Now volume equal to volume is a constant volume. That means what? V2 is equal to V3. Then once at constant volume we are going to supply heat. That means what? Heat in Q in, we are going to supply certain amount of heat. When we are going to supply a certain amount of heat, right? That what will happen? Sudden there is a rise in pressure and temperature at point 3. That is nothing but what? P3 and T3. If the sudden rise in temperature and pressure, what happens? Explosive force is going to create. That explosive force, what it will do? It will try to push the piston from TDC to BDC. When the piston is moving from TDC to BDC, expansion is going to take place, but there is no heat transfer at all. That process we can call it the adiabatic expansion process. 3 to 4. Once it reaches the BDC, right? Then what we are going to do? We are going to open the exhaust valve. Once exhaust valve, in that exhaust valve, what will happen? The heat is going to transfer from system to the surrounding at constant volume. The heat is getting rejected at constant volume. Volume remains constant. How it is constant? We can see now. V4 is equal to V1. At constant volume, heat is getting rejected. This is what Otto cycle, the working principle. Then you are telling, right, heat supplied at constant volume. That is very important. How much amount of heat you are supplying? At constant volume. But dear students, diesel cycle, in Otto cycle you are supplying heat at constant volume, but in diesel cycle you are supplying heat at constant pressure. That you have to remember. You are supplying heat in Otto first cycle. You can take Otto. You are supplying heat at constant volume, remains constant. Okay, in Otto. In diesel, what we are doing now? You are supplying in diesel cycle. You are supplying heat at constant pressure. But heat rejection, you can take in Otto, heat rejection constant volume, but here heat rejection is at constant volume remains constant. That you can see now. The small major difference between petrol and diesel engine cycle, Otto cycle and diesel cycle. You are adding heat at constant volume in Otto cycle, and you are rejecting heat at constant volume again in the Otto cycle. But when it comes to diesel cycle, you are adding heat at constant pressure and you are rejecting heat at constant volume. This is the only one major difference in the Otto cycle and diesel cycle. Okay, now how it is then? How to write the equations now? Now you are telling, right, you are supplying first one you are telling, right? You are supplying, this is the first important point, right? You are supplying certain amount of heat at constant volume. That means what? Qs is equal to m into, what we can do now, we can take specific heat at constant value, that is m into cv into highest temperature, that is T3 minus T2. So heat is supplied at constant volume cv. Okay, then next again you can take heat is getting rejected at again constant volume. That means what? M into cv into highest temperature, that is T4 minus T1. Both heat addition and heat rejection, they're going to take at constant volume. That constant volume cycle we can call it as a Otto cycle. Generally sometimes we will call it as a constant volume cycle. That constant volume cycle is nothing but what? That means Otto cycle. That means both heat supplied and heat rejections, they're taking place at constant volume. This is what? Otto cycle. Now what is the difference in the diesel cycle? Now diesel cycle, you can see here now, dear students, again power processes are there in the same power processes are there in the diesel cycle also, but you are supplying heat at constant pressure. The 2 to 3, the 2 to 3 is what? Pressure is constant. You can see now PV diagram, you can draw a horizontal line. Here it is a 2, right? That means what? P2. It is a 3, that P2 is equal to P3. The at same pressure P2 and P3, you are going to supply certain amount of heat. That heat supplied we can mark here as Qs is equal to M into Cp, specific heat at constant pressure, Cp into that highest temperature, that we can take it as T3 minus T2. Heat supplied. Then this is what heat supplied. Then heat rejection is what? Qr is equal to, again heat supplied is constant volume or constant pressure here now, but heat rejection is at constant volume. Hence what we can do? mcv into T4 minus T1. Yes, in diesel cycle heat supply will takes place at constant pressure, whereas heat rejection takes place at constant volume. This is diesel cycle. But when it comes to Otto cycle, we are going to supply heat at constant volume and also we are going to reject at constant volume. This is the difference between Otto cycle and diesel cycle when it comes to working of the cycle. Okay, what are other differences are there for Otto cycle and diesel cycle, or petrol engine and diesel engine, that you can see here, dear students. When it comes to fuel ignition, spark plug we are using in petrol engine, whereas in diesel engine we are using a fuel injector for a fuel ignition to burn the fuel. One option. Then second option, fuel type. In gasoline engine and Otto cycle operated engines, we can say gasoline is a petrol engine, we are using petrol or gasoline as a fuel in the engine. But when it comes to diesel engine or compression ignition engine, we are using diesel as the fuel. We can take diesel or biodiesel or any other biogases we can take. Fine. Next, but in petrol engine gas mixture we are supplying to the engine, but when it comes to diesel engine we are going to supply only air to the engine. Compression ratio, the compression ratio is nothing but what? It's the ratio of total volume to the clearance volume. It will be there in the both engines, but petrol engines they having less compression ratio, whereas diesel engine having more compression ratio. Okay, that's also we can see here now. Then thermal efficiency. Thermal efficiency, when it comes to thermal efficiency, is nothing but what? It's the ratio of work done by engine to the heat supply. When it comes to thermal efficiency, the petrol engine is having less thermal efficiency, where diesel engines having, or diesel or compression ignition engine having more thermal efficiency. Then power output, that power output from diesel engine is more when compared to petrol engine. Weight and size, physical characteristics of the weight and size, but diesel engines are somehow heavier than the petrol engine. And applications, we can see both petrol and diesel engine we are having different applications, but lighter applications we are using petrol engine, but heavier applications we are using diesel engine. Yes, quick recall, dear students, if you got one question, compare the different compare auto engines and diesel engines, or Otto cycle operated engine, diesel cycle operated engines. If you got the such questions, that is nothing Otto cycle or diesel cycle, then what you have to do? You can answer like this now. So fuel ignition in Otto cycle is what? Spark plug. Okay, SI engine, spark plug ignition. Then fuel used is petrol or gasoline. Compression ratio is, as I told, 8 is to 1 to 10 is to 8 is to 1 to 10 is to 1. Then thermal efficiency is around 20 to 25%. Okay, now next, power output is less, the weight and size is less, and applications are limited when it comes to auto cycle. Now you come to the diesel cycle. Now diesel cycle, fuel ignition engine. How we are going to ignite the fuel? With help of what? Fuel injector. You can take a FI. Nowadays we can say FI engine, FI engine, FI engine, right? Fuel injector. That fuel injector will help us to give more thermal efficiency and low fuel consumption, and also it will help us to give low emissions also and giving more power. Okay, then fuel type. But when it comes to petrol and petrol engines, right, fuels limited, only petrol or diesel. But here we can use, as I told, diesel we can use, biodiesel we can use. Okay, we can use gases, biogas we can use, producer gas we can use, CNG I can use. So that means what? Different fuels, this kind of fuels I can use in the diesel cycle. Okay, but the compression ratio in the diesel engine or diesel cycle is, it will start from 18:1 to 22:1. That means what? It is having higher compression ratio. The thermal efficiency, as I told dear students, here it is only 20 to 25%, but here it is around 30 to 40% of thermal efficiency we can get from the diesel operated engine or diesel engine. Then weight and size, it is somewhat more than the petrol or diesel engine. But when it comes to applications, right, the diesel cycle operated engines having more applications than the auto cycle operated engine or auto engines. This is how to differentiate the auto cycle and diesel cycle, dear students. I hope you understood this lecture. If you have any doubts, you can comment and you can help me. But I'm seeing I'm doing a lot of videos, but I'm not getting like and subscribe and comment from your end, dear students. Please, if you like, I will bold my sentence. If you like, please subscribe my channel and you give a small support to support for me to do more and more video like this. Okay. Thank you.